Okay, sorry if I've got a bit of a frog in my throat at the moment. Let's just take a look here. Okay, I was requested that we go through solution development. So I'm going to revise this PowerPoint which I sent to you, and I'm going to activate the chat function over here. So if you have any questions, you can enter them here and I will check them throughout the lesson. So let's say, oops. Good morning, everyone. If you have a question, please enter it here. Okay. So I'm going to keep that at the bottom of the screen. Okay, so let's take a look here. Get my laser pointer going. So let us take a look at flowcharts and trace tables. Okay, so a flowchart is a diagrammatical representation of a program. So basically, it is a picture of the program. A trace table is a logical representation of the steps of the algorithm using a table. Now, I'd like you to get into the habit whenever you do a new program that you will do a flowchart and practice a trace table. Every matric exam, prelims and finals, there are between 9 and 15 marks that are dedicated to algorithms. And then the matrics come to me and say to me, but ma'am, you never taught us this. And then I say to him, remember back in grade 10 when we did flowcharts and trace tables and pseudocode? That is those 15 marks in your final matric exam. Okay, so get into the habit when you're doing your PAT, when you're practicing your programming, draw a picture. Okay, think through the program. So we're just going to quickly look at how to do flowcharts. Okay. So the task here is draw a flowchart to assign a variable called number1 to number 7 and a variable called number2 to 9. Okay, so 1 must be 7, 2 must be 9. The flowchart must determine and display the product. Now here's good old maths. This is why in the past, if you wanted to take IT, you had to do maths, core maths. Okay, so the product means times, okay, or multiplication. So let's start here. Remember, your starting of your flowchart is an oval, and the stop is also an oval. So we assign number 1 is going to be 7. That is step 1. Then number 2, I want it to be assigned to 9. There we go. Number 2 is assigned to the number 9. Now my calculation that I have to do is going to say number 1 times number 2. The result is going to be my product. Okay, so here in this step I'm going to write the product is 63. So 7 times 9 is 63. Then I need to have an output. Remember, we are dealing with input, processing, and output. So I have to display my answer, and that will go into step 4. So do you see how easy a flowchart is as soon as you put a trace table to it? Okay, let's just check here. Okay, we're still good. Welcome, we've got 3 participants. Let's quickly see. Welcome, Tiko. It's good to have you all here. Okay. Let's go to our next slide. Okay, so we're going to now take flowcharts and look at it in a more in-depth way. So a flowchart is a diagram of a sequence of movements or actions of people or things involved in a complex system or activity. So that is a very technical term for it. or it can be a graphical representation of a computer program in relation to its sequence of functions. So the reason we say sequence of functions, it's the steps I have to go through in order to get my result. So let's carry on. Let's quickly just take here. Here I had an if statement, so expression if it was true. Do you see that we have arrows everywhere? Now in your exam, if you are required to do a flowchart and you leave out your arrows, you're going to lose marks, because otherwise it's just lines. It doesn't tell me which way. The whole word is flowchart. I need to know which direction it's going. Okay, so if it's true, I need to do an instruction. Else, okay, remember here comes your if then else. We are going to get into that more as we are programming. We're going to do something else. Okay, so let's see here. Here's a definition for trace tables. A trace table is a tool used to track how the value of variables change in a program after each line of code is executed. Now, this is the lovely thing of Delphi. Delphi reads your code line for line, whereas Python or Java will run through the whole program and then go, oh, wait, there's an error. Delphi stops as soon as it finds the first error so that you know where to fix it. Okay, so Delphi in that sense is a better option. It helps you to find any errors. So this tool is helpful for testing an algorithm because it helps you to determine if the algorithm gives you the correct result. So before you even write the code, you need to figure out what the answer is going to be, okay? Or approximately what it's going to be. So that is why you do a trace table. If the result is not correct, the trace table can help you to identify the logical error responsible for the incorrect result. So, how do I create my trace table? First of all, I'm going to identify my variables. Further into the slide, I'm going to explain variables. Then, I'm going to create a table with a column for each line number and a separate column for each variable and a column for the output. I apologize. Then for each row, it's going to be a code line by line and write down the new value. So what you will see is why we put, if I go back to the previous slide, over here, if we get to a loop, now a loop is when a part of the code is going to be repeating until it gets a desired result. So sometimes your trace table might go 1, 2, 3, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 3, then on to 4. Okay, so you will see it's not just going to count 1 to 10. Okay, you will write each step. So if you get into a loop, then you might need to jump back to a previous step. Okay. Okay, so let's get here. So we're going to do line by line and write down the new value. So each time, so even in the loop, you will write down what that value is. Okay. Now, the third algorithm which you are dealing with is called pseudocode. Very funny spelling. You will see IT people are not great. Whenever they will put PH for farming and pseudo PS, we're not great with spelling, okay? So just bear with us. So let's take a look at our task. The task says here, divide the solution into 4 parts. Sometimes the solution might only satisfy 3 parts. Try as far as possible to keep your solution in this order. So let us take a look at how to break up this algorithm. So part 1 is initializing. That means create. It's a big fancy word for create. Another form of this word is instantiate. Okay, so the question here is, are there any counter values or variables used for calculating totals? Okay. Part 2 is our input. Now you've all heard about input and processing and output. Okay. Do you need to enter values? So will the user need to enter something into an edit box? Okay. Then my processing, do you need to perform any calculations? Okay. So I want to do a test that you are going to enter your admin number, and in this number, so we give you a new code to join the IT 10 group. Okay, but we need to make sure that you're an IT student. We can't just have anyone joining our class now. Okay, so we are going to do a specific calculation that will check your data or whatever the user has entered. Then part 4, output. Does the question require any display? Okay, so is my output going to be displayed, or is my output going to be used further, part of another equation? Okay, so use the words input or enter, output, and display in your pseudocode. Okay, then use the left arrow. This means assignment purposes. So what, remember I said to you when we started Delphi, whatever's on the right hand side is going to be assigned to whatever's on the left hand side. I think my camera might be backwards, so I might look a bit funny to you right now. So everything on the right must be assigned to the left. Okay, so therefore if I wrote in maths, area equals half base times height, in pseudocode, I'm simply going to write area, left arrow or assign, half times base times height. Okay, so to understand pseudocode is you need to, in almost English terms, explain to me what your program is going to do. It could be the entire program, or it could just be part of a program that you are explaining to me. Okay, let's carry on. Now we get to input and output. I just want to check if we've got any questions. No, we're still good. And we've still got the same participants. Okay, so the first thing we have to learn to do in programming is input and output. The program is not going to do anything if I don't interact with it. Okay, when I interact with it, it could be a mouse click, it could be me entering information into an edit box. I could use a spin edit to select age, and a variety of different ways. So without input, a program has no data to work with, and without output, the program serves no purpose. Why would I write a program that doesn't display? Okay, so the whole purpose of output is to show results. Okay, let's take a closer look to input. Programs require input from the user. This forms the basis of the calculations, decision-making, and processing that the program will carry out before it produces output. So let's look here. Input, get the data that will be used in the program. Okay, so let's take an example of a new cell phone contact. I phone, or you phoned me, and I want to save your number. So I go and I click on create contact, and it is going to go and check, it's going to do algorithm. So it's going, I enter your cell phone number. It's going to check to see, does your name exist in my database? Okay. So it's going to do a process. It's going to do an if statement, check if this number exists. Okay. And if it does, it's going to display one message. Okay. So say this contact already exists. Else, it is going to say create a new contact. Okay. So my process there, let's just move this out of the way, e.g. doing calculations and marking comparisons, or checking if a cell phone number exists. Then my output is going to be either create a new contact or add contact details to an existing number. Okay. Let's go to the next slide. Now, the IPO. Okay, you have to do one of these for every tab or screen in your PAT. Okay, so that's your home tab and 2 other tabs that you have to create in your PAT. Reason being, in your PAT you will see the requirements are only 1, but not in my class. In my class, you will do all the requirements for each screen. Now, why am I making you do so much work? Reason being, as soon as you do that, you actually think and you plan through your program better. You know exactly what you want the user to do, and you know exactly what the result's going to be. So that is why I require it for each screen. Okay, so let's take an example here. A builder wants to calculate the perimeter and surface area of the floor of a room. You need to decide for yourself what the input, the processing, and the output is. So my input is going to be length and width. If I'm looking at just the perimeter, say I want to draw a line around the edges of my classroom, then I'm going to use perimeter. If I want to paint my classroom, I'm going to need area. So perimeter is 2 times length plus 2 times width. Now please, one thing you need to remember, back to maths, BODMAS. Brackets of division, multiplication, addition, subtraction. So exactly the same principles that apply in maths apply in Delphi and any programming language. Okay. So I'm going to take my values from my left and assign it to the perimeter. Remember, there's our assign sign. My output for perimeter will give me the perimeter, and there the output is going to give me area. You can see this section on page 37 in your Delphi textbook. Okay, so let's take a look. We're going to try we've got a pseudocode and a trace table. So either a flowchart or a pseudocode with a trace table. So it said here, write pseudocode to assign the value 16 to number 1 and value 19 to number 2. Calculate and display the sum means plus or addition, of the numbers. So in pseudocode, I would write there 16 assign number 1, 19 assign number 2. Here's my process. Number 1 plus number 2 must be assigned to sum. Okay, no paragraphs. It is just the instructions in pseudocode. Step 4, output the sum. Okay, let's check it here. So I wrote 16 under my number 1, 19 under number 2. I add the 2 together, 16 plus 19 will give me 35. There's my process. And what is my output going to be? It is going to be 35. So I just want to take a sip of water. This is my 3rd lesson for the day, so my voice is not used to speaking anymore. So just bear with me, please. Okay, let's take a look at another example. This time, the grade 10 learners are selling raffle tickets to raise money for the matric dance. So they think you're such a fantastic group that they are giving you the responsibility to raise funds for the matric dance. Okay. A ticket is going to cost 10 Rand. You should be able to enter the name of the learner. Okay, so here's some input, as well as the number of tickets that the learner wants to buy. Okay, so we've got 2 inputs. Input 1 is the learner's name. The second input is how many tickets. And what is my calculation probably going to be? I'm going to have to calculate how much it costs. So the program must calculate the amount to be paid and display it with an appropriate message. For example, Tabang, you need to pay 50 Rand. To solve this type of problem, we need to develop an algorithm and to provide a step-by-step solution to the problem. Pseudocode, pronounced pseudocode, okay, for this program will look as following. Program pseudocode is an algorithm written in basic English for the user to understand. So basically, pseudocode is you need to be able to explain to one of your friends who doesn't take IT what your program's going to do. Okay, so you can't go and talk Delphi code to them because they're going to stare quite blankly at you. Okay, so let's take a look. Calculate that my task is calculate the price of tickets. I'm going to ask the name of my learner. Then I'm going to get the name from the input. I'm going to ask the number of tickets to buy. I will get the number of tickets from my second input. I'm going to process and do a calculation, number of tickets times 5, and assign it to amount payable. And then I need to display something. So here I'm going to display a message. You need to pay and the amount. Okay, so let's take a look here. So my input here is name and number of tickets. There is, and the components I would use is EDT name and EDT number. Okay. My process is number of tickets times 5, assign my amount payable. My output is going to be display the name, remember, display name. So Jeremy, you need to pay, and there's my variable amount payable, and that will be the calculation from number of tickets times 5. Okay, and what will I use to display it? A panel. I could use a label. I could use a memo. I could use a show message, but in this instance, we're going to use a panel. Okay, so let's take a look here. We've got Solution Development Act 1, Activity 1. The formula for calculating the area of a rectangle is the length of the rectangle multiplied by the width. So length times width. With this in mind, I need to create an algorithm for calculating the area of the rectangular room. 2, the owner of the house pictured here wants, so here we've got the picture, wants to tile the doors of the lounge and bedroom too. So let's see. Here is lounge and here is bedroom 2. Okay, so consider the following items when creating your algorithm and IPO chart. Step 1, what is my input? Step 2, what processing must occur? Step 3, write out the steps for the algorithm, either with a pseudocode or a trace table or a flowchart. And 4, display your algorithm. Okay, so we're just going to quickly, you can work that out. This is very basic maths that you would have done already from primary school, and you will be able to, if you had values there, if I said 2 times 4, you would be able to work out the calculations. Okay, so let's carry on. We've only got about 5 more minutes. Tomorrow I'm going to carry on with this slide, and if you have any queries, then you can let me know. So input is always captured in the text property. Okay, so very importantly, this is now where we start looking more specifically at Delphi. When I speak about a string, I'm not just talking about letters. A string is anything that I am displaying. So words, letters, characters. Characters can be anything, your at, your hash, exclamation, any of those ones. Okay, so input is always captured in the text property. So when we are dealing with an edit box, we will say it's EDT name dot text. Okay. Numeric input added to the edit needs to be converted into numeric data type. So what this means is I can't display an integer. So let's quickly backtrack. What is an integer? An integer is a value which I will use as a calculation. Okay, so, but I can't display. So I can't display my math sum. So I need to convert it into text using string to int or int to string. Okay, so string to int function means take my string and convert it into an integer. So as you can see here, string to int functions converts a string to an integer value and assigns the integer value to the integer property of the output. Okay. Now, so if I wanted here, I'm creating a variable calendar1 dot day, and I'm going to enter something in here. So I'm going to use my edit box, and then I'm going to convert it into and assign it to this variable. This calendar1 dot day is a variable. So when do I use string to int and when do I use int to string? So again, we're working backwards. Take what you've got. So I've got in my brackets, I've got text, which I can't do a calculation with, and I want it to be able to do a calculation, so it's going to convert to an integer. So string to int. Take what you've got to what you want. Okay. Now, if I were to display the result, okay, so for example, my sum, and this was IH, for example, then I would have int, I've got an integer to string, but we will go through this again, so don't worry about it too much. Okay, so let's take a look at variables. I'm going to see if I can get through the slide before the session ends. Variables in programming are used to store values. A variable should be declared before it is used. So here I'm going to go through the rules of declaring your variables. Very importantly, the name of the variable must be indicated. You also need to tell me what type of data it is. So is it a string? Is it an integer? A char. This is a new word to you. Char is a single character. Okay. Boolean stands for a yes, no, true, false. So it can be one or the other. A real, this is when we work with division, and double is when we are, remember in the binary code that we learned, that's when we get into much bigger numbers, multiply by 10. Okay, so there's times, not so often, that we're going to use a double. Okay. Each data type is restrictive in the type of data it can contain, otherwise errors will occur. Single memory locations can hold onto one value at a time. So think of in your RAM, when I create a variable, I'm saying to my computer, hold this space, hold this little slot for me. I'm going to place some information in there. And it is only active as long as that process is going on, or the procedure. Okay. If the value is replaced, the previous value will be overridden. So this we will go through again, especially when you learn to use the iCount. We declare a variable by using the keyword var for variable, followed by the variable name and a colon, and the data type that will be stored in the variable. Okay, this comes from page 39 in your Delphi textbook. We are going to carry on. Sorry, let's quickly just see. Teko, I see there's a question. So does the assignment arrow mean equals? Yes. So basically, it's we don't necessarily call equals because equals is part of a process or a calculation. We rather refer to it as a sign. Okay. So in Delphi, remember we did the colon equals. That is a different way of writing a sign. But we don't use that in pseudocode. We use the left arrow. Okay. We will get to loops at a later stage. We are not quite there yet. I know they've been doing that already in the Zoom lessons or the STEM lessons. I'm going to work through this process so that we do not lose anyone, and I have to then keep going back. Okay. It was so good to have you all here. I'm hoping to see more of you tomorrow, and look sharp. Remember, go and, even if you have to stick your head out the window, just get a little bit of sun. Okay, all this staying indoors is not so good for us, but we have to be at home. It is for our own safety. I miss you guys, and I hope to see you soon. Have a wonderful day. See you tomorrow, same time, same place. Goodbye.